Hello, chemistry students. Here are some corrections for page 228, 28 through 31, in case you struggled. So, number 28 says, write a balanced net ionic equation for each reaction. Again, I'm going to go through the whole thing, so I'm going to balance this first. So, I'm going to go ahead and just balance it up here. 1 PB, 2 nitrates, 1 nitrate, so I need a coefficient of 2. I'm going to choose a different color though. Let's try this. 1 PB, 2 nitrates, coefficient of 2 in front of hydrogen nitrate. 2 hydrogens, 1 sulfate, so it's now balanced. Okay, so then remember our next step is anything that is in the aqueous state of matter, I'm going to break up into its ions. So I have to figure out what charge this lead had. Nitrate has a charge of -1. There's 2 of them, so that's a total negative charge of -2, so this has to be a lead with a +2. So I have Pb plus 2 aqueous plus 2, because of the subscript of 2 on nitrate, NO3 -1 aqueous plus 2H plus, and again the 2 comes from the fact that there is a subscript of hydrogen, plus SO4 -2 aqueous yields, and again the lead sulfate stays the way it is because it's a solid, plus 2H plus aqueous plus 2NO3 -1 aqueous. So that's my complete ionic equation. So now I want to identify my spectator ions. Okay, so the ions that exist on both sides of the equation exactly the same way. So notice 2 nitrates exactly the same way. Notice 2 hydrogens and 2 hydrogens. So I'm going to leave those out, and I'm going to write my net ionic equation, which is Pb plus 2 aqueous plus sulfate -2 aqueous yields Pb SO4 solid. So for letter B, we're going to do the same thing. Right? We're going to start by balancing it. So I have 1 lead and 1 lead, 2 acetates and 1 acetate, so I need a coefficient of 2 in front of hydrogen acetate or acetic acid. 1 hydrogen, 2 hydrogen, so I need a coefficient of 2 in front of hydrogen chloride or hydrochloric acid. And 2 chlorines and 2 chlorines, so it is now balanced. Next step, I'm going to do my complete ionic equation. Again, I'm going to take everything that's in the aqueous state of matter and break it up into its ions. So I have Pb plus 2, because acetate has a charge of -1 and there's 2 of them, aqueous, plus 2 of these acetates because of the subscript, plus 2 hydrogen ions, plus 2 chloride ions because of the coefficient in front of them. Again, I leave the lead 2 chloride the way it is. Then I have 2 hydrogen ions and 2 acetate ions because of the coefficient in front. Next, I want to identify my spectator ions that exist in exactly the same way, so same symbols, same charge, same state of matter on both sides of the equation. So this acetate ion is the same, and this hydrogen ion is the same. So to get my net ionic equation, I'm going to rewrite my equation, leaving out my spectator ions. So I have Pb plus 2 aqueous plus 2 Cl minus aqueous yields Pb Cl2 solid. Letter C, same thing, right? We want a balanced net ionic equation. So we're going to start by balancing it. We have 3 sodiums, and we have 1 sodium, so we need a coefficient of 3. We have 1 phosphate, and we have 1 phosphate, 1 lead, or 1 iron, 1 iron, and 3 chlorine and 3 chlorine, so it is now balanced. So now I'm ready to go ahead and write my complete ionic equation. Again, everything that's in my aqueous state of matter is going to get broken up into its ions. So I have 3 sodium ions, aqueous state of matter, plus, and again the 3 comes from that subscript on sodium, plus PO4, negative 3, aqueous, plus Fe, and again, because chlorine has a negative 1 charge and there are 3 of them, I have a negative 3, so this has to be iron with a positive 3, plus 3 chlorides, 3 sodium ions, again from the coefficient, 3 chloride ions from the coefficient, and my iron 3 phosphate as a solid. So now I'm ready to do my my net ionic equation. And again, to do that, I'm going to identify my spectator ions. So I have 3 chlorines and 3 chlorines exactly the same way. I have 3 sodium ions and 3 sodium ions, so I'm going to leave those spectator ions out. So my net ionic equation is phosphate ion, aqueous, plus iron 3, aqueous, yields iron 3 phosphate as a solid. And letter D, again, the first thing I'm going to do is balance this. So I have 2 ammonium and 1 ammonium, so I need a coefficient of 2 in front of ammonium nitrate. 1 sulfur, 1 sulfur, 1 cobalt, 1 cobalt, 2 nitrates, 2 nitrates, so it is now balanced. So now again, I'm ready to do my complete ionic equation. Again, I'm going to take everything that's in the aqueous state of matter and break it up into its ions. So I have 2, because of the subscripts, ammonia, I have sulfide, I have cobalt, and again, because nitrate has a charge of negative 1 and there's 2 of them, my total negative charge is negative 2, so this has to be cobalt with a plus 2. And again, we have 2 nitrates because of the subscript. And again, the cobalt 2 sulfide doesn't break apart because it's a solid. And then I have 2 ammoniums and 2 nitrates. Now, some of you are probably starting to see the pattern if you haven't already. There is a pattern here. So I'm looking for my spectator ions. Here's my 2 ammoniums exactly the same way. Here's my 2 nitrates exactly the same way. So remember my spectator ions I'm going to leave out when I rewrite and write my net ionic equation. So I have sulfur, negative 2, so sulfide, plus the cobalt 2 ion, yields the cobalt 2 sulfide solid. So that is number 28. 29, write a net ionic equation for each reaction. So basically the same thing, the difference being here, they haven't given us our products. So we have HCl aqueous plus AgNO3 aqueous. Now again, this is a double replacement reaction. So hydrogen and silver are my positively charged ions, so they're going to swap partners. So, and those are both going to be ionic compounds, so hydrogen is +1, and its partner is going to be nitrate with a -1. Now, I look at my activity series or my solubility rules for ionic compounds, and I'm looking at rule number 2 that says nitrate and chlorate salts are soluble with few exceptions. So I need to include my state of matter, and I'm going to put my aqueous. And then my other product is going to be silver, Ag. It's on our helper sheet, only ever has one possible charge of a +1, and it's going to be with chloride, which has a -1 charge. And again, I'm going to look at my solubility rules, and number 4 says chloride and iodide salts are soluble, but an exception is compounds of silver. So this is a solid. So now, again, I'm going to go ahead and I'm going to do my complete ionic equation. So again, I'm going to take everything that's in the I need to balance it first. But everything that's in the aqueous state of matter. So let's look at balancing this. 1 hydrogen, 1 hydrogen, 1 chlorine, 1 chlorine, 1 silver, 1 silver, 1 nitrate, 1 nitrate. This is a skeleton equation. That's a balance equation. So complete ionic equation, breaking things up. H plus aqueous plus Cl minus. And remember, this is not a requirement. I'm just always going to do it because some people won't have seen the pattern yet. Okay. Break up the hydrogen nitrate because it's aqueous, but I leave the silver chloride together as a compound. Now I'm looking for my spectator ions, and notice question number 30 says identify the spectator ions. So hydrogen ion and nitrate. So to identify them, right, two choices. I can say H plus and NO3 minus, or I can say hydrogen ion and nitrate. It does not matter to me which way you choose to do it. So then I'm ready to do my net ionic equation, and I'm going to leave those spectator ions out. So I have chloride aqueous plus silver ion aqueous yields the silver chloride solid. So that's letter A for 29 and 30. All right, letter B. Again, I'm going to go ahead and rewrite this. So I have lead acetate and lithium chloride. Now again, who's alike? Lead and lithium are my positively charged ions, so they're going to swap partners. So my products are going to be lithium, which has a charge of +1, with the acetate, which has a charge of -1. And again, that's on your helper sheet. And, I need to look up the state of matter for that. So, I don't have acetate on here, but I have, number 1, salts of the alkali metals are soluble. It does have lithium listed as some exception, so I might wait a little bit and just see what the state of matter is on my other compound, which is lead with a charge of +2 like it had on the other side, with chloride, which is a -1, so I have PbCl2. So chloride salts are soluble, but lead is listed as an exception. So this is actually my solid, and this is my aqueous. So next step, I'm going to balance this. So balancing this, 1 lead, 2 acetate, so I need a coefficient of 2 in front of lithium acetate, 1 lithium, 2 lithium, so I need a coefficient of 2 in front of lithium chloride, and then 2 chlorides and 2 chlorides. So now I'm ready to make this a complete ionic equation. And I'm going to break up everything that's aqueous. So Pb plus 2 aqueous, 2 acetates because of the subscript, and it has a -1 charge, 2 lithium ions, 2 chloride ions, 2 lithium ions, 2 acetate ions, and my lead chloride solid. Looking for my spectator ions. Again, I have 2 acetates here and 2 acetate ions here. I have 2 lithium ions and 2 lithium ions. So again, I can say C2H3O2 negative and Li plus, or I can say acetate and lithium ion for number 30. So now we're ready to do our net ionic equation. Again, we're going to leave those spectator ions out. Pb plus 2 aqueous plus 2 chlorides, -1 aqueous yields PbCl2 solid. Letter C, same thing. Okay, so again, first thing that I'm going to do is write my equation. And again, this is a double replacement reaction. Oops, sorry. So, geeks. So, sodium and chromium are positively charged. They're going to swap partners. So, sodium has a charge of +1. It's now going to be paired with chloride, which is -1. I look at my states of matter, my solubility rules. Rule 4, chloride and iodide salts are soluble, and sodium is not listed as an exception, so that's aqueous. And chromium has a charge of +3, and I know that because there's 3 chlorides, each with a negative charge, so that's -3, so this has to have a +3. And then phosphate is PO4, -3, so I crisscross down 3's and then reduce. For phosphates, I'm looking at rule number 5, and it says most are insoluble, and an exception is alkali metals and ammonium, and neither of those are chromium, so most are insoluble, which means I should put a solid. So I'm going to balance this now. 3 sodiums, 1 sodium, I need a coefficient of 3 in front of sodium chloride, 1 phosphate, 1 phosphate. 1 chromium, 1 chromium, 3 chlorides, 3 chlorides, so it is now balanced. So now I need to write my complete ionic equation. Again, everything in my aqueous state of matter is going to get broken up. So I have 3 sodium ions. I have a phosphate ion. I have my chromium +3 ion. I have 3 chloride ions. I have 3 sodium ions. I have 3 chloride ions. And then I have my chromium phosphate solid. Again, spectator ions exist exactly the same. Sodium exists exactly the same, and chloride. So again, I can identify them down here by saying Na plus and Cl minus, or I can say sodium ion and chloride for number 30. Now I'm ready to go ahead and do my net ionic equation. Again, I'm going to leave those spectator ions out. So I have PO4 negative 3 aqueous plus Cr plus 3 aqueous yields CrPO4 solid. So that is 29 and 30. So that brings us to number 31. Identify the precipitate form when solutions of these ionic compounds are mixed. So this isn't asking for a net ionic equation or anything of that nature. So again, I need to decide who's alike. Hydrogen has a positive charge and barium does. So my products are going to be barium with sulfate and hydrogen with chloride. Now, I can either name them or write the formulas. If you write the formulas, you have to write the formulas correctly, which are BaSO4 and HCl. Doesn't matter to me. They're both ionic compounds. You would do symbols, charges, crisscross, lowest whole number ratio. Now, we want to know which one's the precipitate. So for sulfate, I'm going to look at rule number 3, which says sulfate salts are soluble, but barium's listed as an exception. So I think this is the precipitate. I'm going to check on hydrogen chloride. That is number 4. Chloride and iodides are soluble, and again, this is not listed. So the precipitate is the barium sulfate for letter A. And again, you could have written it this way as well. For letter B, again, who is swapping here, because this is a double replacement? The aluminum and the ammonium. So my products are, I have aluminum with hydroxide, and I have ammonium with sulfate. Now, again, you could also write the formulas. If you do that, you just have to make sure you write them correctly. Aluminum hydroxide is AlOH in parentheses 3, and ammonium sulfate is NH4 in parentheses 2 SO4. So, again, it doesn't matter. They're both ionic compounds. You get the formulas by writing symbols, charges, crisscross, lowest whole number ratio. So hydroxides is rule number 5 on our solubility rules. And it says hydroxides are insoluble, and alkali metals and ammonium, neither of which these are. So I think aluminum hydroxide is my solid. I'm going to confirm that sulfate is soluble. I look at rule number 3 that says sulfate salts are soluble, and ammonium isn't listed. So this is aqueous. So the question was, which one's my precipitate? The aluminum hydroxide. Letter C, we have silver and nitrate and hydrogen sulfide. Again, silver and hydrogen are my positively charged ones, so they're going to swap partners. So silver is now going to be partnered with sulfide, and hydrogen's going to be with nitrate. And again, both ionic compounds, so I could name them or write their formulas. And again, the formulas come from writing symbols, charges, crisscross, lowest whole number ratio, right? plus 1 minus 2, this is plus 1 minus 1. Okay. So now, looking at my states of matter, I'm going to look at rule number 5 for silver sulfide, and it says that most are insoluble, and the alkali metals or ammonium, neither of which these is, so we think this is the solid. Nitrate is rule number 2, and they are soluble with few exceptions, so this is aqueous. So the question was, what is my precipitate? It's the silver sulfide. Letter D, again, it's calcium and lead that are alike, so they're going to swap partners. So calcium's partner is going to be nitrate. And lead, and this is lead 2, because again, this is -1 and there's 2 of them. And with chloride. Again, you could write their formulas as well. They're both ionic compounds. Doesn't matter which way you do that, okay? Now, in terms of their solubility, for calcium nitrate, I'm going to look at rule 2 that says nitrate and chlorate salts are soluble with few exceptions, so this is aqueous. So lead 2 chloride, I look at rule 4, chloride and iodide salts are soluble, and some compounds of lead is listed, so I expect that this is my solid. So that is my precipitate. And the last one, letter E. Again, it's a double replacement reaction. Calcium and nitrogen are the ones that are alike and that are going to swap partners. So one of my products is calcium with carbonate. And my other product is sodium with nitrate. Again, I also could write their formulas. If I'd want, that's fine. And then in terms of our rules, carbonate is rule number 5. Carbonates, phosphate, chromates, sulfides, and hydroxides, most are insoluble, and calcium's not listed, so I think that's the solid. Sodium nitrate would be rule 2. Nitrate and chloride salts are soluble with few exceptions. So my precipitate in this one is the calcium carbonate. So if you were kind of struggling with your homework, I hope that helps. Have a great day. I'll talk to you tomorrow.